Hey everybody, today we'll do another video, and today we will just do another basic decimal uh, decimal conversion, right? So and then I will do some binary to decimal conversion, because this we're going from decimal to binary, right? So let me do another number today, because I think one of the examples yesterday I was not clear enough why we do the subtraction method, right? I think the division is very clear, but I think the subtraction we can do another problem. Let's say that we want to convert 35 in decimal, right? Let's say that we want to convert 35 to binary, right? So we're going from decimal to binary. This is base 10. 35 base 10 mean decimal, and we will have to convert this to binary. Okay. So in the subtraction method, right? So what I do is the following that we did yesterday. So basically, we start from base 2 again. Binary is base 2. So we start from the first number 2 to the 0 power, second number 2 to the first power, third number 2 to the second power, and the fourth number 2, I will say base 2. You know, these are numbers, but technically it's a base, to the third power, right? And then we go and say 2 to the fourth power, and then, but we got a 25, right? So let's see. When we do this math, for those people that they don't know exactly what we're doing over here, basically any number, and let me just do this quick, any number 2, or any number, it doesn't matter. It can be 1 million, 100,000, whatever, right? Any number to the 0 power is 1. You can actually put that in the calculator. Any number to a 0 power is 1, right? Now, okay, and basically what we're doing here is any number to a 0 power is 1, so that stays 1, right? And then when this comes here, any number multiplied to the power, well, this 2 is being multiplied. For example, this one right here is 2 times 2 is equal to 4. And then the 3 is the 2 to the third power is 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. That's how we get 8 in this power 2 to the power of the third power, right? Now that we know this, let me just do a little quick. So, but here, now we know how to do that, right? So now let's do this, right? So here, in this case, this is 1, and then 2 to the power of 1 is just that number, so it's 2. 2 to the second power is 4. 2 to the third power, we say already that is 8, right? But if I add this, do I get 35? Up to now, well, I know up to now I'm not gonna get it, right? But 2 to the 4th is 16. But still, it doesn't equal 35. So I had to go, this number right here gave me the opportunity to go one higher, which is 2 to the 5th power, right? It's 2 to the 5th power, right? 2 to the 5th power is actually 32. See? So what you do, 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, right? So 2 times 2 is 4. Times 2 times 2 equals 8. Times 2 equals 16, right? And times 2 is equal to 32. That's how we get 32, right? Now, I think I am very clear how I did this. Okay, let me do this again, right? 2 times 2, this is equal to 4, right? And then I bring this down, right? So then times 2, right? Okay, so this is 8 here. And then I bring this down, right? And then I say times 2, right? And then this is 16. And then I bring this down, and I bring the last one down, right? And I bring this 2 down, and this is times 2. It is equal to 32, right? That is clear, right? How we get that 2 to the 5th power is equal to 32, okay? Now, and this is very important because this is how we get the numbers for computers. We get the numbers for how many bits, how many gigabytes a computer holds in memory. It's very important how this number have been, this number system was actually held to work, working with computers. Now, here I get 32, right? So now we can actually say something, right? So now, the number that is close to 35 is 32, right? And this is the point that I want to make today about this. The reason why I am doing this video again, because I think it's important to understand. So 35 minus 32, right, is equal to, well, this is 3, right? And then this is 0, right? So basically the difference 3. Okay, so do I have another number that is less than 3? But here's the important part, right? So I put what number I am using this, right? I already used this. Okay? So I put 32 there, right? Now, what number, the remaining, the difference that I have from 35 is 3, right? So what is less than 3? Well, less than 3 is 2. So I put, so I take this 3 and I say minus 2, right? Well, 3 minus 2 is 1, right? And I get that I am already using this number, right? And I add that to this number, right? So then, what is the next number? Well, the next number is 1, right? I got a 1, so 1 minus 1 equals 0. And I stop there, right? I am done. Now, I circle this number. Then, because I'm talking about now this is important here. So plus 1, right? So when I add it, this is important. 32 plus 2 is 34, plus 1 is 35. So you want to make it sure that this number here, you want to make it sure that this number here, the sum of the numbers is that you actually circle here, and when you did the math, when you did the subtraction, adds up to whatever number you have over here. 32 plus 2 is 34, plus 1 is 35. So now I know that is correct. Now what I do here is just basically fill the ones and the zeros. If I had a number that I use, I put a 1 on it. 1, right? I didn't use this one, right? So I put 0. I didn't use that one, I put 0. I didn't use this one, I put 0. I did use this one, I put 1. And I used that one, and I put 1. Right? So that is 1, 0, 0, 0, 1, 1 represents 35. Right? 35 in base 10. Okay. Okay, cool. So okay, so that is representation for base 10, right? For the 35 base 10. Okay, so that's fair enough. I think the division was clear, so I'm not going to do the division. I think the division is clear. I mean, I can do it, but let's do it real quick, right? So let's do, okay, so 35 over 2, right? And here I do remainder. Right? So 35 divided by 2. 35 goes, 2 goes into 35 17 times, right? So it's 17, but it actually is 17 and a half. It's 17, well, yeah, 17.5. Okay, so 17.5 equals 17.5. So you write 17. You don't, in remainders. It goes 34 times, right? So 34th time. I'm sorry. Into 35, it doesn't go evenly, but it goes on 34. So it's equal to 17, right? With remainders 1, right? Remainders 1. So remainders 1 here, okay? Now, let me just put an equal sign here, it's better. Alright? So now it takes 17 again. Wait a second here. Okay, so in this case, okay, so yeah, that's correct. So in this case here, okay, so in this case, if I have 17 over 2, right? So 17 into 2 goes how? I'm sorry, 17 divided by 2 goes 8 times, right? 8, right? Remainders 1 again, right? So I got another 1. Then 8 divided by 2 is equal to 4. Remainder 0. And then you got 4 divided by 2 is equal to 2. Remainders 0. And then 2 over 2 is equal to, well, here we gotta be careful because here it goes 1, right? But the remainder is 0, right? See? It goes 1, but the remainder is 0 again. Then the last one, I got 1 divided by 2, and we say that yesterday technically is 1/2, but you want to write 1/2, so it goes 0 times, but the remainder is 1. See? Now, I write that answer from bottom to top, and it's like I said yesterday, right? Most significant bit, least significant bit, right? From bottom to top, and this is equal to 1, 0, 0, 0, 1, 1 in binary. Okay? So that's it. That's it for that. I think that's a good review. We already know how to convert from decimal to binary. Now let's do the opposite. From binary to decimal. Okay? So let's do that. So okay. Okay. Let's do to convert the following numbers to decimal now. To decimal. Okay, here I can change this to binary because now we're doing binary to decimal. Binary to decimal. Binary to decimal. Conversion. Okay, so now we can do binary to decimal conversion, right? So let's say that we know that we say like yesterday that the number 12, I already say it, but let's say the number that you just did, right? So we had a 1, 0, 0, 0, 1, 1, right? That is the number that the answer that we just got it on the last problem. Okay, so let's convert this number. Let's convert this number to a decimal, okay, and see what we get. Okay, so let's see. When we do decimal to binary, from binary to decimal, it's actually easy. It's an easy process because I already have the binary. All I have to do is look for some type of numbers, and I know the binary is base 2, so I use the same technique, right? The only difference, this will be multiplied by 1, this will be multiplied by 1, and by 1, and by 1. Whatever I have as zeros, I don't have to even worry about it, right? So here, I will say 2 to the 0 power. Okay, let me just, because this is going to get a little more, I need more room in this, right? So let's do 2 to the 0 power, right? And then that multiply times 1, right? Actually, yeah, I mean, you can actually do this. You can actually put parentheses right here, times 1, right? Then you put a plus sign here. Then you say 2, and you say in another parenthesis, you can put another set of parentheses, and you say 2 times 2 to the 1 power, and then you say plus again, and you say in this case, see, over here I multiplied by 2 because I had 1, I multiplied by 1 because I had 1 in there. Now you're going to multiply this by 0, right? So 2 to the 3rd power, right? I'm sorry, to the 2nd power. That's the 2nd power. This is 1, this is 2nd, right? Then plus another number, which is this is next 0 anyway. But you know what? Let me just because I want to make this clear. I want to make it sure that you guys get it, right? Okay, so here we say that it was 1 times 2 to the 0 power plus 1 times 2 to the 1 power, and then plus 0 times 2 to the 2nd power, and then plus 0 times 2 to the 3rd power, and then plus, right, and then plus 0 times 2 to the 4th power, right? This is not clear, so let me just, okay, so to the 4th power, right? Then here, so I have many, I already covered the 1, 2, 3 zeros, so plus, last one is 1 times 2 to the 5th power, right? Okay, so now let's do the math here. Okay, so I don't have to worry about this, right? I don't have to worry about them, not at all. I have to worry about this, I have to worry about this and this, right? So let's do this and see if we get the number that we got, right? And I cannot say what it is because we know what it is already, but we want to try if we get the right number, right? Okay, so this here is 1, okay, because 2 to the power base, okay, so 2 to the 0 power is 1 times 1 is 1, right? And then this number 2 to the 1 power is 2 times 1 is 2, and then these are zeros, this plus 0, and this is a plus 0, and then I get, we say that 2 to the 5th power is 2 to the 5th power is 32, right? Okay, so now you add these numbers, right? So forget about that, right? And you get 32. So you don't have to write the zeros, but if you want to be consistent and learn, it's a good idea to do it. So 32 plus 2 plus 1, okay? So, and that is equal to 35. That is equal to 35, and this is 35 base 10. See? Now we went back and we got the number again, right? We got 35 base 10. Now, just note, this here usually some of the test books write it base 2. right? It's binary, so it's right. It's usually they put a base 2 in here, and they put a base 10 in this number. Sometimes they put a parenthesis and they write it like this sometimes. They write like that and they put a base 2 here. Either way, doesn't matter. I mean, it's either way. A lot of test books do the base 2. Some test books, they don't do the base 2, just basically, just binary. You know, when you get ones and a bunch of zeros like this, it's a binary number. Okay, so that is that number, right? Let's say, for example, you got another number, another binary number that is 1 1 0 0 1 1 1, right? So 0 0, right? Same thing. Actually, you know what? Let me do 1 1 1 1 1 0 1 and see what is the number, right? Okay, so let's convert this number, right? So here again I do this, right? So 1 1 1 and I got 4 digits, right? So this number is going to be close to probably about 20, I don't know. But it's going to be a little more than 15 because I got a 5 bit. 1 2 3 4 5. But anyway, it's going to be greater than 15. But we'll try. We'll see what we get, right? So okay, so let's do it. Let's do it. All right. So here, if I do so I do 2, right? Times 1 to the 0 power, and then I got 0 times 2 to the 0 power. Then I got 1 times 2 to the 0 to the nope. This is to the power 1. This is power 2. Alright, and then is 1 times 2 to the 3rd power. Alright? So notice when you're doing this 0 power, so 1, 2, 3, 4, when you end up on the 3rd power, that means that you started at 0, so you have 4 places. 1, 2, 3, and 4. That's a good way to check it too. Okay, so so here is a 3rd power. Alright? This here is the 4th power. So how many I have? 1, 2, 3, 4, right? And 5, so I need 1 more. So 1 times 2 to the, so I have 1, 2, 3, and 4, okay, and this is the 4th power, right? So, did I cover all of them? I got this, I got this, I got this, I got this, and I got this. Okay, so let's do the math. Okay, so here is 16, right? And here is 8. Here is 8. And here is 4. And here is 0. And oops, and I forgot to multiply. Okay. And here is 1, right? So this is 1, this is 0, this is 4, this is 8, this is 16. Okay, let's add them up together, right? So we got 16 plus 8 plus 4 plus 1, right? So 16 plus 8 is what? It's 24, right? 16 plus 8 is 24, 28, and 29. Here you go, 29 base 10. And that's how you convert from binary to decimal, right? So this is how we convert binary to decimal. And then how can I check it again? Well, just I can actually divide this by 2, and I will get this one again using the process, the reverse process. Okay, so this is another quick video on how to convert from binary to decimal now, and I hope you learned something. Eventually, if I can get the resistors and the LED, probably I will do some little project, maybe a counter in Arduino using the table, 4-bit table, and yeah, so using a little Arduino microcontroller, so we can actually test how these binary numbers work and actually doing the practical in the software and hardware part of it. Alright, thank you for watching. I hope you learned something in this video.